Charges I will explain as it comes. The charge of colloidal particle, since it is charged, when we add an oppositely charged electrolyte or ion inside, suppose ferric hydroxide salt, it is positively charged. To this salt, if I add a negative ion, this charge get neutralized, colloid get precipitated. So, the conversion of a colloid to precipitate is called coagulation or flocculation. It is called coagulation or flocculation. Next property is Brownian moment. When you watch any colloid under a microscope, like many of our students, they are always in a restless way moving, in a zigzag motion. So, the zigzag motion of colloidal particles is termed as Brownian moment. It will be always in a zigzag fashion, it will be moving. That zigzag motion is called Brownian moment. Brownian moment makes the colloid stable. How? This is also a 1 mark question, because when there is a continuous interaction between the dispersion medium and the dispersed phase, they are always colliding each other, so that it is moving in a zigzag fashion inside. That zigzag motion of the colloid is called Brownian moment. Next one, charge of colloidal particles. As I told you, colloids have got a charge. Why the colloids are charged? There is one and only one reason, that is the preferential adsorption of any one ion on the surface from the solution. What does it mean? Suppose I add silver nitrate solution and potassium iodide solution, I mix together. Potassium iodide to silver nitrate. Of course, there will be silver iodide is formed. On the surface, there will be accumulation of I minus ions. This will be adsorbed on the surface. Depending upon the situations, it varies. But one example I am telling, when silver nitrate mixed with the potassium iodide, silver iodide is formed. I minus ions will be adsorbed on the surface. In a vessel, when you take, there are so many silver iodides where I minus is adsorbed on the surface. Like that, many particles are there. So, of course, this is negatively charged now. Similar way, as I told you, ferric hydroxide salt, it has become positively charged due to the preferential adsorption of Fe3 plus ions. Due to the preferential adsorption of Fe3 plus ions, it has become positively charged. As2S3 arsenous sulfide is a negatively charged salt due to the preferential adsorption of S2 minus ions on the surface. So, we have positive salts also, negative salts also. Remember always, a particular colloid will have only particular charge, either it will be positive or it will be negative. A colloidal solution cannot be positive as well as negative. If it is arsenous sulfide is negative, the entire colloid will be negative. Ferric hydroxide is positive, the entire salt which you have taken will be positive. It is not that half is positive and half is negative. The entire vessel will have only one particular charge. So, this is an example of positive salt, this is an example of negative salt. These all are very important question. Why this has got a positive charge? Answer is due to the preferential adsorption of Fe3 plus ion. Why it has got a negative charge? The answer is because of the preferential adsorption of S2 minus ions. Now, you see, due to the adsorption of I minus ions or S2 minus ions or Fe3 plus ions, I am taking a colloid in a U tube where I am putting two electrodes, one is positive, one is negative. I am filling ferric hydroxide salt inside. As you are aware, the salt is of positive charge. Which electrode it will be moving? The colloidal particle will be moving towards which electrode? Since it is positively charged, the whole colloidal particle will be moving towards a negative electrode. The entire ferric hydroxide particle will be moving towards a negative electrode. The movement of colloidal particles towards the oppositely charged electrode under the influence of an electric field is called electrophoresis. If it was arsenic sulfide salt, which is negatively charged, it would have been moving towards which electrode? Positive electrode. Means depending upon the charge on the colloid, it will be either moving towards a positive electrode or moving towards a negative electrode. That movement of colloidal particles under the influence of an electric field is called electrophoresis. Now, the point is Hardy-Schultz rule, which states that to coagulate a particular colloid, to precipitate out a particular colloid, you have to add an electrolyte. Higher the charge on the electrolyte, more effective will be the coagulating power. That is the meaning of Hardy-Schultz rule. More the charge on the electrolyte. Suppose I am writing SO4 2 minus, Cl minus, which has got more charge, sulfate ion has got more charge. To precipitate a positively charged salt, this is more effective than Cl minus. Higher the charge on the electrolyte, more effective will be the coagulation. If I write Al3 plus, Ca2 plus and Na plus, which will be more effective in coagulation? This will be more effective in coagulation because it has got more charge. Higher the charge of the electrolyte which is added, more effective will be the coagulation. That is what is called Hardy-Schultz rule. This question has been asked so many times. You will be given 2-3 ions which is more effective in coagulation and why. So, since there are potassium ions in the liquid solution, this happens in a vessel. There are so many AgI with an adsorption of I minus on the surface. K plus will come and stand nearby. This is adsorbed on the surface. Since it has got a negative charge, K plus ions from the solution will come and stand nearby. There will be a force of attraction between oppositely charged ions which form a double layer. This is a single layer, then a double layer is created. There is an electrical double layer created on the surface. On every colloidal particle the thing happens. This is I minus and K plus is attracting the I minus and symbol is standing. It is not adsorbed. It exists as a second layer. So, since there is a positive and a negatively charged species, a double layer is created. Of course, a potential will be created, between a potential difference will be created, which is called electrokinetic potential or zeta potential. The potential difference between the electrical double layers is called electrokinetic potential or zeta potential, and the double layer is called Helmholtz double layer. The double layer is called Helmholtz double layer. Now comes to one board question. Ferric chloride is added to a cut. Cut is whether there is a cut in your finger or leg which is bleeding too much. If we add ferric chloride, the bleeding will stop. Two questions were asked, which is more effective in coagulating, whether Fe3 plus or Ca2 plus, which is more effective in coagulation. According to Hardy-Schultz rule, Fe3 plus is more effective in coagulation. Why it coagulates? Why the blood get clots? Because blood is a colloid of an albuminoid substance which is having a negative charge, which get precipitated or coagulate when we add a positive electrolyte inside. So, it gets coagulates or precipitates. The last question in the series is, this is also a very important question, last but one question, because deltas are formed where river meets sea. Why? Means there will be river which is not containing any, supposed not to contain any electrolytes like sodium chloride or potassium chloride, nothing is present in river. It is supposed to be pure water without any electrolyte. When it meets sea, this is river, here this is sea. Sea contains sodium chloride, potassium chloride, so many ions, various electrolytes. Here lot of mud deposit which is called delta. Deltas are formed where river meets sea. Why? The answer is clear. Where river is a colloid of mud. River contains lot of mud particle which is a colloidal solution. When it reaches sea, it gets neutralized or coagulates because of the electrolytes present in the sea. So that it will precipitate down, it will settle down. Clear to you? River is a colloid of mud. When it goes to sea, it will precipitate down or settle down. So, wherever river meets sea, deltas are formed. Now, you have seen, this is the last question of the series. You have seen in our kitchen, modular kitchens, just above the gas stove, there is a chimney is kept. You have seen in many of our houses, just above the gas stove, there is a chimney is kept. In that, how it functions, that is called a cottrell smoke precipitator. That's called cottrell smoke precipitator. It is a fashion in all the modular kitchens nowadays. You can see how the cottrell smoke precipitator works. Smoke from the gas stove, it contains so many dust particles, carbon and other charged particles. When it passes through the chimney, it contains two electrodes. One is of positively charged, one is of negatively charged. Smoke when passed through the chimney, negatively charged particles will move towards a positive electrode. Positively charged particles will move towards a negative electrode, so that it will settle down, it will be collected here. The tray once in a while will be clean. The smoke going out will be free of dust particle, which will control pollution. So, the precipitation of colloidal particle using electrodes is being used here. This all are the board questions which are being asked. Children, hope you understand the chapter, and all the best for you. Thank you.